be. But again, so if you're not cool with recording, then, welcome to turn off the camera, whatever the case may be. But we are here again. Welcome back to week 2 of our coding boot camp. We're going to go over algorithms and data structures. We're going to build off of what we did last week, doing a lot of hands-on stuff. Promise there'll be very few slides. This is day 3 of the course, even though, since we only do it twice a week, there've been much more days between the beginning and now of the course. And what we're going to cover today is basic algorithmic problem solving. So we're going to wrap up a few things from last time that are, we talked about data types last time, and we're going to finish up with one last data type. That was a little too complex to fit into the lesson we did on Tuesday or on Thursday. So we need some more time to devote to it. And it's like one of the coolest parts about Python. So it's going to be fun. And then we're going to talk about a couple other control structures. We talked about a sequential control structure on Thursday where the computer reads your code that you write from top to bottom, left to right. And then we had the conditional control structure with our if statement. We're going to go over a couple more, and then we'll actually go through solving some algorithmic problems and some tools to practice. I'm going to give you a problem set to practice between now and Thursday, or now and whenever you get done with it. And that's really what this week is going to be about. So it's one of the more complex topics. This can get really deep. There can be a ton of math in it. But that's not necessary. And I've picked out a set of things that we could start with that'll focus on working with strings and lists, which is a lot of what you're going to be doing anyway with most algorithmic problems, regardless of what it is. But it should be very light on the mathematical stuff. So before we dive into today's content, quick review where we should be at the end of last week. If everybody's following along, we should have been able to run the Hello World program from a command line out of a file, the main.py file. So when we left on Thursday, I encourage everyone to take that framework and add something to it and build out something on top of that. Did anybody do that, mess around with it, and build out a thing that they wanted to share or show us?
Mine isn't finished. It needs more work.
Not finished? Does it run at all? Does it work?
It runs in the console.
Okay. But you didn't get to run out of the main.py?
No.
No.
All this stuff about how to hook it up to, yeah, I got to go through my notes and do that again.
Okay. Well, we're going to build off of that and use those same patterns today. So if you didn't go and mess around with it, I encourage you to. Don't just sit back and listen to this class or watch it. You got to get your hands on it, and you got to do these exercises and do the things. So take these parts right along with me if you can today. If we're going too fast, raise your hand. Tell me this is going too fast. I can slow down. But it's really important to go in between classes, definitely, and beyond that, because it's going to take more than the 18 hours that we're together here to really nail these things. And it's a lot of it's just muscle memory. Honestly, it's just going through the same patterns over and over again until they become really familiar to you and you don't have to think about them. All right, so that's, we did basics last week. We're going to build off of that. And that is pretty much it for the slides. Let's go right over into our favorite, which we were discussing earlier, our Python Anywhere environment. So once again, where we should have been at the end of last week, if you followed everything along or you're catching up, you should have been able to make a file that is called, here, I'll list what we have. So it should be main.py, and it should just be in your home directory. I can make this console a little bit bigger if we need, so we can see the print. And we should be able to run that exceptionally simple. Technically, it's an application by just typing Python 3 to invoke that, and then the name of the file, main.py, and it should print out our hello world, right? So this should be the place where we were. And to look at that file, you can go over on the side, go into files and open it up in the GUI. I already have mine open over here. And this is the code itself. And we're going to be working mostly here today. So we're not going to be doing as much directly in the command line. We'll go over there to show that things are working the way we expect them to and whatnot. But we can mostly do it right here, and then we'll just use the console down at the bottom. But this shows, again, it's just running in another Python console here at the bottom, running the same script. All right, so to reiterate what's happening here as far as control structures go, because we're going to go a little more into depth than the ones we covered, and then add a couple more that we're going to need for solving algorithmic problems and using algorithms to their fullest coolness. And this is sequential control structure. So it's reading top to bottom, left to right. And what happens is it reads this definition here of the main function, sees this colon, and expects a code block to be indented 4 spaces underneath it to read what that function should be doing, what it should be returning, all those sorts of things. And then down here, this function or this phrase that we talked about, the if conditional control structure. So it checks to see if this condition is true after the word if and before the colon. And we're looking at this reserved variable, seeing if it is main. And sorry, I don't know who's not on mute, but we got some background noise. If you could mute it, that would be helpful. And so then again, the colon, and then an indented block is expected, so 4 spaces, and then we're going to do something. So print main. So this is the conditional statement. And there are other things that could be done with it. So a basic condition is what we did here. We just checked one condition to see if this value is if this condition is true, and then we moved on. We can add this other things to this phrasing and make it much longer or more complex logic. So we'll do that with an example of a function. We'll wrap it into a function. We'll just say compare, and we'll compare 2 things, A and B, which right now those are just variables. So we're going to compare A and B. It's going to expect this input. It takes us down to an indented block. And then we'll use that same control structure of the conditional logic to check to see if I could spell if right. So if, and then we'll just compare the 2 things together. We'll say, like, if A is greater than B, then return a string that just says A is larger. And then if we want to check another condition, we can add this phrase called elif. So that's short for else if, and it's one word. So ELIF space, and then another condition. So we could say if B is larger than A. This isn't a logic class, so again, there's probably faster ways to do this, but this is to be explicit and show you what the language, the syntax is. So then we're going to return the opposite, so A is larger. So this is checking 2 conditions, and you can string these together pretty much as you want to. If you have several conditions that you want to run through, all of this do this. And again, I can make this larger if it's too hard to read for everybody's screen, if that's a little bit better. And then to end one of these, it's the final condition, or like the base condition, is just else, the word else colon, and then you're going to enter the indented block, and that's the otherwise condition. So we've already checked if A is larger, we've already checked if B is larger. So the else condition would just be if they're the same. So we just say A and B are equal.
So it does you a fucking favor.
Cool. So
you don't need to put any kind of test in else, right? It's just like the one left over from
in else, yeah, there's no condition here. It's just like if these other conditions above it have not been met. So the way the computer is going to read this is when it gets down, when we call this function and give it some sort of values, it's going to read in here and compare this and check this condition. If that's not met, it'll move on to the next piece, check to see if this is met. If that's also not met, then it just goes down here and executes this block of code. So this is the final kind of catch-all thing. So then following the same pattern, if we want to call this compare function, we're going to put it inside this because we're just returning and we want to be able to see it on the thing. So we're going to replace our main with compare, and then let's just compare 5 and 3. So we expect to say that A is larger, right? And then compare the other ones. We say 5 and 8. Expect to say that B is larger. And if we do compare 5 and 5. And so this would be, compare numbers. And we save this and run it. It should give us the output that we expected down here. So A is larger, B is larger, and A and B are equal. So that's a simple example of the sort of just conditional control structure of the if else statements.
Jeff, I have a question.
Sure.
Is on your compare statements down there.
Mhm.
Can you use alpha characters?
I'm sorry, what you mean? Between,
Okay, like where it says print compare 5-3, could you say print compare A and B or something?
oh yeah,
'Cause,
absolutely. Yeah. You mean
yeah, okay.
comparing like strings?
Yeah,
Yeah, sure. You can, but the way I wrote this is larger and smaller, so it'll work better with numbers, but you absolutely could. So if we say A and A, it'll still say that they're the same.
yeah.
Yeah. See, it's gonna say A and B are equal. So yeah, you can absolutely use these same comparison operators like we have in the past. Use any comparison operator, the equal sign, or not equals if you wanted to. And you could compare strings to each other. You could compare numbers to each other. Keep in mind the thing that we talked about, you can't compare different types. So if you have an integer, you can't compare it to a floating point number. If you have the string of a number like number 9 written as a string in the quotation marks, you can't compare that to the integer 9. Those sorts of things. So the data type is really important to keep track of what you're putting into it as your input. It's a good question though. Any other questions? Cool. Okay, so we're gonna move on. If you have anything else that comes up, please feel free to throw it out
Is
there.
there a reason you didn't choose to place those print compares underneath main?
Underneath in this definition of main up here, you mean?
Sure, because that's what you had been invoking before, was just to call main and have
Right.
it render its code. Why didn't you place those underneath main?
Because that's a good question, because I wrote another function compare. So this
Sure.
function is not related to this at all. There's no connection.
No, but
So they're in different scopes. So I could
okay.
have put these print statements in place of these return statements, if I wanted to, and then run the compare function to get those to spit out.
Sure,
But
but it does work if you do it that way.
yeah, it does. Yeah, if you put say print functions instead of a return function up here.
No, underneath main, underneath return hello world, you put in your print compare, blah blah blah. If you had just
Oh,
relocated
if I
that
put
up
it under the main
above.
function and then, yeah,
Yeah.
absolutely. Yeah, you could do it
And
that
then
way
you
too.
call
Yeah. And then
main and it's going to
just call
execute
main and
whatever.
keep it that way.
Yeah.
Yeah, you could do it that way too. And just stack everything
Okay.
up in main. Absolutely. Yes. Yes. That's a fair question. Fair point. I really just want to hammer home the fact, and thank you for calling that out. And I'm glad you asked that. I really just want to hammer home the fact that you can write in the functional part of your code down here if you need to.
Mhm.
And like this is where you're calling things and making all sorts of things. Absolutely for an architectural choice or stylistic choice or how you want an application to flow, you may have reasons to just keep adding things to main and build it in there and then just call it that way. So you only have one call down here that's just main and all your print things are up here. Absolutely. You could do that. Does that answer your question?
Yep.
Cool.
Yeah, I was just wondering if there was a logic reason as to
No, this is more for just
why you were doing it, because
being
my
explicit and demonstrative. Yeah. So a lot of what
yeah.
we do, and that highlights a good point, is a lot of what I'm doing in this course is to show sometimes very verbose and much more writing than you would want to normally do. There are more efficient ways to do these things, but it's really to show kind of the best, the most explicit way of writing these things out. So it's very clear what everything is doing and where it's doing it.
Okay.
Cool. But yeah, there are also very many opinionated ways of doing it. There's some style guides that tell you the best way to do things. Some other things are just left to you to make up your mind. And ultimately, it doesn't really matter with most of these things. So it is really just a choice. So yeah, you could do it that way you're saying, wrap it into the main function and just have the one call at the bottom of main. That's totally fine. Cool. Any other questions before we
Yeah,
roll
because
on to
right
our
now
next?
the way it's written, there's no purpose in main.
There isn't.
It
There
has
isn't. In
no
this
longer
function,
any reason to exist.
nope, we're
Yeah.
not doing anything with it. So it's there. We could remove it and it would function. This all would function the same way that it was.
Okay.
Cool.
Now, remind me again, how you, the exact steps over in the corner where it says run, is that what you're using to?
Yeah, up here when I hit run, yeah, that's what actually
Okay,
executes the code.
okay.
Jeff, what happens if you run that in Python? Because when we ran the def main in Python, it printed hello world.
Great question. I love it. Okay, let's hop over to my other console and let's do it. So it printed hello world, and you saw the code change that we did, and we no longer call that main function that prints hello world. So now, first of all, what do you expect to happen? before I hit enter. What do you think is going to happen?
I think it's going to say hello world because you haven't saved it.
Oh, okay.
Or
Maybe.
did you save it? Did
I
I
don't know.
not see
Now I
that?
don't remember. Now I'm second guessing myself. I'm not sure.
Huh.
Okay. So let's find out. We'll hit main. We'll run the main function. And so there it is.
Okay.
It takes the same stuff that I put. So the point here is that whatever is run, whatever is called under this piece of in this block of code, that's what's going to come out. That's what's going to run when you access this. And this again, this construction is called the entry point to your application. So
Thanks for doing that. That shows more of Christopher's point, I think.
Yeah.
Yeah.
Yeah, absolutely. And again, to like what Christopher was saying, we could put all of this up here and, change this and then just call main, but that's just a what I would call refactoring. It's a different way of doing the same thing.
Mhm.
So cool, great questions. Anything else before we move on? No? Okay. All right, excellent. So all right, the next couple of control structures we're going to talk about are iterative control structures, meaning that they're going to go in loops, and they are appropriately called loops. So another piece that I didn't mention a lot in sort of syntax is if you put a pound symbol in front of something, hash mark, hashtag, whatever we're calling it now, that comments out the code. So this piece of code right here, when I add this line in here, it's not going to run. The interpreter will ignore this piece entirely and move on. So this is sort of the things, if you just want to write something out and explain what something is, you could do this in your code. Keep it to a minimum, but there are reasons that you would want to do that. So the two kind of loops we're going to talk about are for loops and while loops. Now, for loops are one that you're going to use a ton. They're not very efficient. They're way, way, way more efficient ways to do it, but this is the basic. This is the basic way of what we call iterating through, unfortunately called iterables. So any of you remember the 4 data types that we talked about, the tuples, which were in the parentheses, the sets, which are in the curly braces, and the lists, which are in square brackets, and then the dictionaries, which are the key value pairs in curly brackets. All 4 of those data types are what they call iterables. And that means that you could take those things and iterate through the entirety of them and do something with each element that's inside of that thing. So I'm going to show you what I mean with a for loop. So the way that you write a for loop is you quite literally just write the word for, but we're going to put this in a function again, just so that we can call it the way we have been and get used to putting things in functions, because that's what you're going to be doing when you're writing algorithms, is you're putting them in functions most often. All right, so we're going to do something that's just going to show us what's in a list, and we'll give it this arbitrarily named ls, which is what it's going to expect in when we call this function. And that list is going to be an iterable of some sort. It doesn't have to necessarily be a list. It could be, it could be other things that you can iterate through, like I said, tuples, anything else, because we're going to make it very simple and just do for. So we're FOR space. And then another variable name that you come up with. It could be anything. It doesn't matter really. Same naming conventions as any other variable in Python. I'm going to use item to show that we're getting each item out of this iterable. So we say for the name that you decide, space, and then the word in. It's also reserved words. You see the reserved words are highlighted in blue in this code editor or this text editor. And then you name your iterable. So for us in this function, it's going to be that ls that we said. So for item in the iterable list, whatever it is that we're looking at. And then we're going to do colon to show that there's going to be another code block. It should expect an indent. So this will indent twice, right? So we should have 8 spaces from the side here on line 15. And this is what we want to do for each item in whatever list that we get. So all we're doing is showing the list. So with this one, I'm actually going to put the print statement in it, because if I did a return statement, it would only return the last one. So this is something I want you to seriously try playing around with to see what it does. I'm going to do print to show you what it does for each individual item. So this is going to print out to the screen each item that's in a list. So once I've done that and defined it, I'm going to get rid of all this down here, and I'm going to keep this pattern of writing the code that we're going to do sort of in this bottom part. And again, we could do it up here in the main function and then keep main down here. But I want to keep focused on this just so that, we're aware of it being there and doing different things. So right now we're not going to be using either of these. the main or the compare, we could even comment those out. It would still work, but they're just being ignored. So what I'm going to do is show, I'm just going to call show list directly. It's not going to be wrapped in the print because this, instead of returning, is printing itself. So it's going to print the items itself. And then I'm just going to put a direct list into this just for demonstration. So that it'll print everything that's in it. So we'll just put 3 strings in here. But I mean, it doesn't matter. We could put an integer or any other data type. Really makes no difference. Put another list in here if we wanted to. You know what? Let's do that. Let's just put another list in here with something in it. The letter G. Okay. So now we got our list, and we're calling show list. So it should, when I save it and run it, it should print each of those things out on a new line in our console down here at the bottom. Because what it's going to do is it's going to read, and here we go. So it's going to read this 4 item in list, and when it enters this block, it's going to print that item each time and then go back to the next one in the list and do that code, and then go to the next one in the list and do that code. So here we go in that same order. We got A, B, the number 6, and then here's a list. This is how lists look when you just print them out. So it's with its brackets, and it shows it's got the string inside of G. So those are for loops. Again, you're going to use. Go ahead.
Yeah, let me ask this. If
Sure.
you on the G, if you had multiple elements inside that, would it show them all, iterate through them all by itself?
Yep.
I
It
think
will.
you need another apostrophe.
I do. I lost control of that piece for a second. So, all right, here, let's run it like that. Thanks for asking. So it's going to keep those in its own spot, right? So you can do what's called nesting with these. So you can, if you know you have a list of lists, and let's say each one that comes in is going to have its own sub list of things inside of it, you can put, here, let's just make this a list real quick. We can put items inside if we need to, but we can just put these 4 things inside of themselves and keep going down. This is going to make it a lot slower too, because each time you think it's going to multiply, it's going to make it a lot slower to process all of this, that if it has to go through each one of these items and then each one of the sub items that's inside of it each time. But I'm going to do it just to have kind of the same stuff in there. All right. So what we could do is we could say, do another 4 inside of it, inside of this item. So since we know that the item is list, let's just get rid of this entirely. So we just go inside of this. So now we're inside of each item. So now if we imagine this that we're going to iterate through and picture this in our heads, we're inside of the first outer square bracket, and we know that the first item we see is going to be another list. So then we just say for the item in that list. And so you're going to need to come up with another, variable name for this. So like, I'm just going to use X for this one. So for X in item, colon, and then go down to another indented block and print X. And you do those things and just go through, and this should work that way to print those out. Let's see. Maybe I'll break something somewhere. Nope. So as I said, it's got the same data over and over again, but it did the same thing and went down and took each single one out of the inner lists and just printed those on its own line after that. So you can make these for loops can get nested as many times as you need to. So if you have lists of lists of lists or several layers of depth of these things. And again, it doesn't have to just be lists. This could be any iterable. It could be tuples, it could be sets, it can be dictionaries, and for loops will work in all of that.
Okay.
Any questions about for loops? Again, these are kind of seen as the beginning level of stuff. There's way faster ways to do iterative processes a lot of times. For loops are they're slow. They're really slow, notoriously slow, but they're also explicit, so they're easy to read, right? There's advantages to them, there's disadvantages to them, but you're going to use them a lot, especially when you're starting out and you're first learning. This is going to be a huge part of what you're doing with any algorithms or solving any problems. It's going to be using for loops.
I have a question here.
Sure.
Okay. in your function, right? Show list,
Yep.
you say for item and then for X.
Yep.
Are those? I'm not sure. I don't understand how those are. I mean, how you? Because
Those,
usually, if you start some kind of variable, you have to define it as something, right?
not really. It's just saying that, I expect there to be things inside of this iterable, right? So this
Right.
construction in Python is saying that whatever this thing is that follows in, we expect it to be a tuple, a set, a list, or a dictionary. It's going to be something that can be iterated through. And this is just what we're calling in this phrase all the things that are inside of that iterable. So these are both, this is just a placeholder name for any general iterable that you could put in here. And this is just any name for the thing that's inside of it so that we can reference that thing inside of it. So what it's going to do is when it loops through this and it finds that item, it's basically just going to assign, it's going to kind of like run this item equals, or not equals, I'm sorry, item is, and then it's just going to take the first piece and say, the first time it runs through, it's going to say item is G. So instead of you explicitly writing item is G, you're going to say, use this term item and assign each thing out of that list to this each time you go through the loop. Does that make sense?
Okay, yeah. So it just kind of does it on the fly by itself, right?
Yeah. Yeah. It sort of entails, like, this phrase entails that it's going to take that first thing and assign it to this variable item. And then it's going to use that variable name in the block of code that follows this colon. And this block of code just so happens to say, loop through that item because we did a nested loop. But this could have any number of things that it does, right? So we could have print item in here too if we wanted to. But the idea is that they're just variable names that we're assigning as it's rolling through.
Okay.
Is that more or less clear?
So if you ran it now, what would print item say?
Okay, let's do that. What do you expect it to say while I'm writing this in?
Okay, I'm expecting it would.
Because follow it, like read it.
I'm expecting it would print each one of the contents of each one of the brackets down there in turn.
Okay.
So you'd
All
see
right.
it 4 times. Yeah.
Yep. Okay. Let's find out. All right. So what it did this time is it still ran this right here
Yeah.
is the outer loop. So this is the item right here. So it's the
Right.
full list of this first piece right here. And then the inner loop is when it enters in and hits these parts. So this is the inner
Okay.
for loop when it's printing X, is hitting the individual pieces out inside of this list.
And for each one of and that would do that for each one of the G7 this.
Yeah, each one of the inner lists. So again, that's why you can see how this nesting things will make it just go huge on how much you're going to do. Because if this is, if this list has 100 things inside of it and the outer list has 100 things inside of it, then the first one you loop through has to loop through 100 times, and then the second one you loop through has to loop through 100 times, right? And that's huge. So
Yeah, have fun debugging that one.
yeah, right. Be wary nesting these. Sometimes it is the solution, but be really careful with it. If you can try to find something else to do, maybe avoid it, because for loops even by themselves are slow. But each time you add a layer of it, it's going to just get that much slower. So cool, good questions. Any other questions about for loops?
Just these new languages, they seem to promote you being, they enable laziness. You don't
Yeah.
have to declare your variables up front. It will do
Right.
it on the fly as you go. You don't have to do the normal programmatic things that were always classic. You are enabled to be lazy.
Yeah, absolutely. And that's, that's the goal of programming is, good programmers are really lazy. That's the idea, is they're trying to make this as automatic as possible.
Sure, by throwing the computer under the bus to get there.
Right. Yeah.
Turn my 5-cycle compute cycle into a 800 compute cycles, but I don't care. I got cycles to spare.
Exactly.
So, yeah.
All right.
Brute
So
force algorithm.
yeah. Right. So the last major control structure we're going to talk about is the while loop. Now this one is a lot of fun. There's a lot of cool stuff you could do with it, but it's also dangerous because you can get yourself in an endless loop. The way that this differentiates from a for loop is that this will just run based on a condition. It will check to see if a condition is met, and it will run the block of code underneath it as long as that condition is met. So if you set up your code to check something that's always going to be met, that code is always going to run. And if you're doing this on your own computer, be very careful, because while loops, again, it could just crash your computer and go into an endless loop, and you'll just have to close everything out and start over again. If that happens, don't be afraid to close out your terminal if you're working in your own terminal. And if that happens in the browser, I think this has some fail safes against it to where you may chew up all your CPU and you have to wait a few hours to reset it or something like that. But be careful with it. While loops are somewhat tricky. You're not going to use these as much starting out, but they're good to know. And there are times when you absolutely will need to use them. So the way that we do this, we're building into a function. So I've already started by defining a function. And I was trying to come up with a good way to show how we would do this, why we use a while loop without getting into things like recursion and stuff like that and calling the callback again. So I was thinking of the analogy of like trying to fill up a box automatically when you give it the maximum size that can go in that box. So what we're going to do is we'll just do, we'll make a function that fills containers, and you pass it a maximum amount that you want. So it's going to be an integer that you pass. It says this is the most that could fit in here. And then what we're going to do is one, again, very explicit way of setting something that will stop this while loop that we're going to write is to just declare a variable that's a count. And then you adjust that count as you loop through. So I'm going to show you what I mean here. So I'm going to set it to 0 for this and start the count at nothing. And basically the count is going to represent what's inside of this container, this bucket. Imagine we're filling a bucket with things. So what we're going to do is we're going to have a while. So we write while, just the word while, W-H-I-L-E, space, and then we're going to have our condition to check. So it's going to be just like the if statements where we're just checking some logic conditionally. So we're just going to say while this condition is met, execute the code that follows. So we're going to say while count is less than maximum. We're going to do a couple of things in here, right? So what we want to do is if I'm going to increase the count so that this will exit the loop. And I want to do that first so I don't forget. So I'm going to do count. And in Python, the way we increment something up is plus and then the equal sign together with no spaces. And we could do the same with decrement to go down. If we started, like say the count was 100 and we wanted to work backwards, we'd do the minus sign and equals. And we're just going to go up by 1 on this. And then also, so we have some sort of output. So we'll just say the bucket contains, and then I'm going to teach this one, which is cool. We're going to use this a lot. This is called a formatted string. So before I write this string, actually, I'm going to reseed it with just the letter F and then my quotation mark with no space. And what that's going to let me do is I can put in a variable call in this string. So an open curly brace, and then I'll put count, and then close curly brace. And what that's going to do, items, complete my sentence. What that's going to do is it's going to take whatever the count value is and just put it in this string and print that string out to the console as it changes. So then we can add, just to know.
Is that a
Go ahead.
is that the braces with the little points on them?
Yep. This is curly brackets.
Curly brackets.
Yep.
That's what I'm looking for.
All right. So what this is going to do is it's going to check to see that the count is less than the maximum that we give it, and it'll increase. While that's true, it'll increase the count by 1. It'll let us know that it's added something to our fake bucket here, and then at the end it'll return the overall count. So let's go ahead and call this and see how it works. So let's give it a maximum of 5, arbitrary number, and we'll run it. And as we can see, it prints out each one. Oh, and I didn't print this, so the return didn't kick out because I just returned it. So, it didn't show out to this thing because I didn't tell it to print it anywhere. But this printed each step that it went through. So you see it contained 1 item, then 2, then 3, then 4, then 5. So there are 5 items in the bucket. So that means it went through 5 times like we asked it to. And then it exits.
Oh, I
So,
see.
yeah.
Your argument to your function is how you set the maximum.
Yep, it's the maximum. So this is for the condition that we're checking to say as long as our count is less than this maximum, which in our case that we ran it was 5. As long as that count is less, increase it, and then let us know that you added it to the bucket nominally, right? There'll be more code in here. You can put lots more code in here to do all kinds of different things within your while loop. But this is the basic structure of a while loop. And then,
Okay, now it started at 0.
yep.
Now you specified that. Is that the default behavior for
Then
just
it starts.
initializing an integer?
No, that's a really good question. So if we use, so what I've been using, and I was going to call this out in a little bit, but we can talk about it now. What I've been using is what's called literals for these definitions of variables. So the
Okay.
actual, just a number, right? And it could be any number. I could make this 2. I could make this 100. It really doesn't matter.
Yeah.
The other option is we can use the built-in data type of integer and write it out as, and you saw me do this when I was, casting the type from one to another. I used this and I put a string inside of it and it came out as an integer. If you do this with nothing in it, that just means integer. And the default integer really is just going to be 0. So, you don't typically do this kind of thing. You don't typically call out the data type specifically, but you can. It's just more keystrokes. It's like 5 instead of 1 to do 0. But no, there's no hard and fast rule. This has to be 0. You can do it different ways.
There's things I see that are similar to the Ruby that I'm used to, whereas at the interpolation, they refer to that as a count. Would have been like percentage curly bracket, and then you would contain that within your thing, and then it would go do that, whatever code that is, and then insert it.
And you're going to see if you take this
and you add the F up front.
Yeah.
And there it's a do this while this condition is true, and here it's while this condition is true, do this. So they just flipped it, you know.
Yep. And you'll see a lot of that. That's the thing, is that whatever language you start with, pretty much every language does this in some way. It's just a matter of figuring out how each particular language does it. So this is the way Python does it. JavaScript, they're going to do something else, but it's very similar. There are while loops in there as well.
And what does the F stand for again?
So this is for formatting the string.
Format. Okay.
Yeah. So it formats the string. There's a couple of ways to do it. This is one way of doing it. And that lets you call the variables inside by the name. So we call the count variable inside.
And you call a function. Could you insert one of the other functions that we have built?
Oh, like show list inside?
Like show list. Can you do
yeah,
you know what I'm saying? I mean, how enabled is that formatting?
I've never tried. I've usually done it with just variables, but give it a shot. See what happens. I don't know. I'll leave that to you to play around with. Get it to this point and play around with it and let me know what you find. Because I've typically just done it with variables. Or the results. Like if I do another function call, I'll store it in a variable somewhere and then just call that in here. But that's an interesting question. I've honestly never tried that. So anything else? And again, I was tempted to try it now, but I want you to play with this on your own. I want you guys to be in there doing this on your own. So I'll leave that for you to play around with and let me know how it goes. Anything else? This is the last one we want to do before I hop into something else that's also super fun. That's really Python specific thing. Any other questions about these control structures before we hop? Okay. Cool. All right. So I'm going to save this because I'm going to be moving out of here. We're going to do a couple of things. We're going to make another file. We're not going to go back to command line. We'll do it through the GUI for now, which will be simple. But what I want to talk about now is the last data type that's sort of basic in Python, but it's also one of the coolest and it's one of the most powerful ones in Python. It's called a class. And we're going to walk through what it is, how we use it, and we're going to definitely see them when we get into our backend development because Django uses Python classes to represent the database, and we'll talk specifically about what that means. But for now, let's set up where we're going to work on this. So from here, I'm just going to exit back out to my files. So you get there a couple of ways. You go over the little hamburger thing, hit files. I'm just going to click on my username up here at the top, right before it says main.py/. So that's like if you're in the command line, that's like I hit CD ... to go back up a file or up a folder directory. Sorry. And I'm going to go into this file thing. I'm going to make a new file called classes. See, it's suggesting this for me since I was practicing earlier. Classes.py. And again, this is important. File extension. Put py on it. Make sure that it's because otherwise the interpreter may not find it properly. So classes.py. I want to hit new file over here on the right-hand side. It's going to take me straight into the interpreter into, you see up here at the top, it says where we are. So this is like saying print working directory at the top. It's classes.py, straight in the interpreter. So the other thing I'm going to do is now we have this console, this main.py, since we're limited to 2, I'm going to scrap that console that we were working in. So we have space to run inside of our new classes running this one. All right, so.
Just so you know, that doesn't work.
What doesn't work?
Inserting a function into that formatted string.
You already tried it, didn't work? Okay, cool.
It kicks out what the interpreter would have done.
Right. Okay,
what the function was and where the memory location is, but it doesn't actually do anything.
Yeah, it shows it doesn't execute the function. It just shows that it was an object. It says like object or something like that.
What the interpreter would have done had it been a normal function call. Yeah.
Yeah, cool. All right, so that answers that. All right, so what we're going to do here to start with is just somewhat for practice, but also because I'm going to show you a really cool thing about Python that's going to be very relevant for when we do web development. We're going to start by writing that same conditional if _name _ is equal to, so the double equal signs, _main _ colon, and then it's going to be the same thing. We're going to put in whatever code we're going to execute in the bottom of this, but we're going to keep this here, and we're going to start writing classes above it. All right, so if you want, go and throw that in there. Now, classes are great, and the way that you start them are just like, or initialize them, I guess. Well, not initialize, that's for later, but the way that you define them is similar to what we've done before, except we're just going to write explicitly the word class. You can see that's a reserved word because it's highlights in blue. And then we name it just like we have with everything else, where we can come up with a name somewhat arbitrarily. The convention here is that classes start with a capital letter, where everything else we've had up to now with the functions and variables have been lowercase. Classes start with capitals. Oh, actually, I'm getting way ahead of myself here, but I'm starting to define it before I told you what this is. So a class is a template. Think of a class as a template. So we're going to use the example of a car, right? Now think about a car and the things that go into a car. A car can have a make, can have a model, it can have a year, it can have a color, can have a number of seats. But each individual car has those specific things. But there's a larger category of car that we all kind of know. And that fits into a larger category of maybe automobile that includes trucks and other things. And that in a larger category of transport that includes trains and planes and stuff like that, right? That's what classes are. It's these large categories, templates almost, that you can set up and then refer to make what they call instances of that class. So to make this a little concrete, we're going to use car as an example, and we're going to make a car class and then play around with it a little bit, show different ways that we can make them and what we can do with them. So we do this again. We use capital letters to say the name, and then just a colon, and that's it. So now we're already into the definition of our class. It's pretty much that simple. We write the word class, space, and a capitalized word for the name of it. And the classes are going to use some of the data types that we've already talked about, namely the variables and the functions, but they're called something else once they're inside of a class. So classes have attributes and they have methods. The attributes are going to be like the variables, and those are the things that kind of describe it, right? And the methods are going to be functions and things that it can do. So attributes are going to be, again, if we're talking about a car, we're going to have like a make. And again, we can initialize this as just an empty string for now. We're not going to give it a specific make. We're just going to say that cars have makes. They have a model similarly as a string. We set it as a year. And this, again, this could be an integer. This could be a string. We can put a 0. We can make this a string. It really makes no difference. For right now, it's just a placeholder saying that this is what a car has these things generally. Noah, you got a question? No, do you have a question, man? You raise your hand. And I can't hear you if you do. All right, man. If you do have a question, go ahead and type in the chat, and we'll pick it up. But we're gonna keep moving. So, all right. So what we do with this, now that we set these things in there, we said it has these attributes. A car has a make, a model, and has a year. Cool. What does that mean? What do we do? Now down in the place that we've been running code, right? Down underneath in our under our if condition in the main and all that, we're going to say we're going to initialize what's called an instance of this class. So if I want to say my car, and then I just say the name of the class that we're going to do, and then open and closed parentheses. Nothing inside it for now. But now we have this object, my car, as an instance is what it's called of this thing. And it has these three attributes, but they're all blank for now. So we want to set them as something. The direct way to do that from here now, we've made one on line 8, is in line 9. We do my car and then dot whatever attribute we want to set it to. So if we want to say the make is Chevy, because, you know, I think that was my first car. And then we do similarly with the other ones. My car dot attribute, so model is, and then I'll say celebrity. That thing was it was a great car. Such a chunk. And then car dot year. And this again, we said it was a string up there, but if I put an integer in here, it'll work. It'll still work in this particular case. This is really kind of for readability and tell you to keep in mind what these should be. So we should be using strings, but it's not going to break if we use integers. It'll just assign it to whatever we tell it to assign it to. And then to show that this happened, and again, we haven't run this yet, so we're just doing this. So we're going to do another formatted string. I'm going to say I'm a, and then we'll just call those things. So my car dot make, or actually we'll start with year because that's generally how you say it. Like you say year, make, model, right? So my car dot year, my car dot make, curly brackets, space, open curly brackets, my car dot model. Let me see if I'm spelling this right since all the Zoom stuff's in the way. And then we'll close this off, wrap up our print statement. All right, cool. So now when we run this should be defining our car class up here. And then here on line 8, we initialize an actual instance of a car that's my particular car. And then we say that car has these attributes, make, model, and year. And then we're going to print this out that says, this is what kind of car I am. We'll save that and run it. It'll take a second to decide if it likes me well enough to initialize the interpreter and then run this terrible code that I wrote. And it should print out this statement that just says that it's, you know, the car that I told it it was. There it is. I'm in a 1987 Chevy Celebrity. So this is exceptionally basic parts of a class. And we're not going to stop here. We are not going to go into the full depth of what classes can do, but we're going to go through a little bit more on cool things they do. So these are the attributes that we talked about. Other thing they could do is methods. We mentioned this before. So methods are the things that the object itself can do on its own. Antoine, you got a question?
Yeah, it's probably wrong for me to ask since I'm late. I'm sorry.
What's up?
Where did you define underscore name underscore?
Oh, that's from last week. Yeah. So this is a reserved variable in Python that it's kind of it's a convention that runs through when you and I encourage you to look up this phrase, exactly what it means, because we're not going to dive deep into it, but it's basically this phrase what allows us to run this from other places modularly. And I'm going to show actually a demonstration of that soon once we finish with classes. But no, we didn't define this anywhere. This is sort of reserved and already defined. So when we type,
Oh, okay. So
so
I found it.
when we type in this, it's like Python 3 mini.py, it's accessing, this is the entry point that it's accessing to make that work when we run this script from the command line. So
I
that's
didn't
all
know
this.
you was gonna get this deep. Like I feel so like 'cause you said it was basic in the
This is basic. This is basic, man. So
you know they don't even teach us this in basic courses. The only thing they would teach us is like list, if conditions, functions.
yeah, you need way more than that, man. That's what I'm saying. So this is barely, and we're barely even getting into what classes can do. This is really basic class stuff. So what we're going to do here is we're going to do some refactoring. So we're not just constantly adding new stuff to this. But one of the principles of programming is called don't repeat yourself, DRY or dry, right? So you try to make things You refactor, you rewrite your code to try to move it in, into being slightly more efficient. So if I want to make a couple more of these, I can make as many numbers, as many other cars I wanted to out of this class. I can make, your car, somebody else's car, doesn't matter. What I want to do though is I want to make put this method, or I want to put this announcing what kind of car it is into the class as a method, so that it could do it yourself and you can just call it straight from that class. And you don't have to write this print function all by itself out here. So the way I'm going to do that is just define a function within the class like I would any other function, except as you can see, it's indented 4 spaces and it's under this block of code. So it's in the same block, it's within the class definition. And as soon as I define this function, it's going to be a method of this class. So what I'm going to do is just going to say show, let's call it show details. And when you do this inside of a class, it must take 1 argument at minimum. And if I misspell this word every time, self, so that you have to refer to itself. Every class method refers to itself first and always. So now that we have that in there, we can access those sorts of things. So what I'm going to do is I'm just going to copy this whole thing. I'm just going to cut it actually and move it up to this double indented block. So we're 8 spaces off the end on row 7. And I'm going to change everywhere it says my car, because that's a particular instance of the car. I'm going to change this to self. So it's still self.year, self.make, and self.model. And what it's going to let me do is down here, when I call it, I just do by car. Now that it's a method of that, I'll just say show details in the same way that I called these attributes, except it's a function. So I have to put open and close parentheses. Now I don't pass anything to this because the self is implied by the dot, and it's going to take my car. So this should, now that I've done all these changes and I've written all this code, the output down here should be exactly the same. We call that refactoring. So I've written the code differently, but the function hasn't changed, or it shouldn't change unless it did something wrong and I broke it. So let's run it and find out. There you go. So I didn't break it. It still says I'm a 1987 Chevy Celebrity, just like it did before. So you might wonder, is like, well, okay, great. Why, we just move that up there and that's all cool. Why would we do that?
Let me ask a question here.
Sure.
So the part of this that's the method is the def show details.
Yep. This right here. Any function that's within a class is called a method. It's written really the same way as a function, except for this little piece here referring to itself as the first argument. It needs that to be in there, or else it'll break. But other than that, it's a function like any other function.
Okay.
It's just called a method.
For me, it's saying my car isn't it's outside of the parentheses. I mean, outside of the there you go. It was outside of the if statement.
Out of scope. You got what's called scope. So all these indentations and within certain blocks, if you're outside of that block, you'll run into things where it won't find it. So one of the ways that we use these methods, and a real common method that you'll see, is what they call an init method. So it's going to use these double underscores again. So this is somewhat reserved. You'll see this around in Python a lot. So it's double underscore init, which is short for initialize, and then another double underscore. And then we're going to do the same thing with self. So we're basically initializing yourself. And what we could do in here is we can set all of these. I'm going to move these guys over. I'm going to indent them again to put them inside of this method. So all the attributes that we had before, the make, model, and year, I'm now going to set them when I initialize it. Now, to show that I haven't changed anything, let's run this again, see if it breaks. Shouldn't. Still prints exactly the same, so I haven't done anything. So once again, I've refactored it again. I put in another method that initializes. So you may be sitting there thinking, like, hey, why would you do that? Now, this is why I would do that. I'm going to show you why we would do this, because now we can send other arguments into this as an initial, when we initialize this and we call it down here on line 13. So as we see now, we have 4 lines of code to initialize this on 13 and then add the attributes here. By doing it this way, we can put all of these attribute calls into the original setup. So there are a lot of ways to do it. You can explicitly say that this is going to take a make, a model, and a year. You can explicitly do that if you want, and then just set these to say self.make equals the make that you pass it, the model that you pass it, and the year that you pass it. And then you can change all these into, just move these up and put them inside the parentheses. And the arguments that I put up here, the make, model, and year up on this side on line 3, those are not, it doesn't matter what those are. You could change those. Those are variable names again, so they can be anything. So now I've just moved the same 3 values that I had in these rows, and I'm going to take these rows out entirely. So now I've just collapsed this down into those parentheses. And this should, hopefully, work the same way. And it does. Still prints out what it is, the kind of car. Nothing has changed as far as functionality, but now I'm using less lines of code. It's a lot easier to read where everything is. And I'm not repeating myself by saying my car dot something over and over again. There are slicker ways to do this, though. So this is explicitly writing out each individual argument that you want to put in there. There are much faster ways, much more efficient ways of doing it. One of those is to use what's called this idiom. So it's a pot or asterisk ARGS, short for arguments. So args. So 1 asterisk args. And what that's going to do is going to turn all of the arguments that you pass it, which can be 0 or more. It can be 0 or more arguments. And it'll return that as a tuple for you to use however you like. So this is a really good way to put in there. You don't have to find specifically which arguments you want. And if you want to add more later, you can, and you don't have to change anything in here. It's just there. And just it's a 0 or more number of arguments. So then to access these, because it's a tuple, that means that it's ordered and it's a 0 index list. That means that it has to be in that order each time, but then you simply access it like you would any other list or tuple in this case. So you do it by index number. So you write ARGS, args, open square bracket, and then the index number you want, close square bracket. So that's going to be exactly the same order, right? So that means you got to have your make first, got to have your model first, got to have your year third. This, again, should not change anything on the output. So it does it exactly the same way. And if we do, say, put this in different orders, it would mess up what's in here because it's dictating exactly what's where, right? So it's going by the numbers. If I put celebrity first in front of Chevy, then that's going to give us mistaken data. See, now it says make. It doesn't know that that's actually the model and that Chevy's actually the make because we entered in the wrong order of these things. So the way to get around that I like doing is another way to do this is you can add what's called keyword arguments. So to do that, you do 2 asterisks and then KW ARGS, keyword arguments. And this is going to take an arbitrary number, 0 or more arguments that can have keywords. And then they're accessed like a dictionary. So there's going to be key value pair like we did before. So we're going to access it by doing keyword arguments and then the name of it. So we'll be explicit and say make. Do the same thing, keyword arguments, square brackets model. And year. Now what's cool about that is that the order down here doesn't matter. They can go in any order, but you just have to be explicit on what is what. So the way you do that is you say that celebrity, that's the model. So we're going to say model is celebrity. And this is just variable assignments the way we've done it before. The make is Chevy. And the year is 1987. So now when I run this, it should give me the string in the proper order, say 1987 Chevy celebrity. And it does. So it doesn't matter what order I put in my arguments when I call this function, or I call this method rather, it's going to print it out here exactly the same way. So that is a little very, very basic rundown of classes. I want to see if I covered all the things I did, and I did before we move on to covering the modularity and kind of hitting on Antoine, what you were asking before. Are there any questions about those things before I move on? Does this all make sense on how we have attributes and methods, but it's really just the same as variables and functions that we've already looked at?
I do have questions, but I'll wait till after the first.
Okay, that's fine. Do that. All right, cool. So the next thing we're gonna do is say, all right, great, we made this other file and we had that main file we were messing around with. Why are we making all these files? Why are we doing all this? What we're gonna do is we're now gonna take this stuff that we have here, and we're going to remove some of it, and I'm going to show you what's really cool about Python and how we can import things. We've mentioned import statements, I think, briefly before, but this is how applications really kind of get working, and how when you have multiple files running, this is how it's going to run. So what I'm going to do is I'm going to remove by cutting. So I'm going to, Control X. So I'll have this to paste in later, and I can copy it into this other file. I'm going to go back to main and copy it and paste it in there. But I'm going to remove this statement at the bottom, starting line 12, everything 12 and below. Take that out entirely. So now it's just our generic definition of the class in this class's file and nothing else. So I'm going to save that before I go.
But mine won't. I don't get mine won't print.
It won't print.
No.
Uh-oh.
But I'm not using the Linux terminal. I'm using that is a Linux terminal, right?
Yeah, this one down here. It is, yeah. It's Python. It's Python, but it's still a terminal, yeah.
But I'm using Visual Studio.
Oh yeah, if you're doing it out there, yeah, man. I don't know. Good luck. So I'm gonna get rid of this console in Python, or this Python console, so we can run again out of main like we were.
It's the same code that you just wrote.
I don't know, man.
All
right, so now I've gone back over into main. If you're still stuck here in a minute, we can dive in and see what's going on. Let me get through this real quick, and then we'll see if we can get to that. Okay.
Mm-hmm.
All right. So now I'm back in main, and what I did is I copied out from the classes file everything that was in this structure, like it was before, over in that file. So I'm going to paste it in here, so we have exactly what was before. So here we got my car, and it calls this car thing. Now, when I save this, since this is a text editor, it should give me a little warning over on the side that says that this isn't defined. Let's see if it does. And it does. This little arrow says undefined name car. So capital car. It's like, I don't know what this is. So it's already sort of read through and looked and said, you know what? I don't know. You don't define this anywhere. And that's true. We don't define car anywhere in this. So what we're going to do at the very top of the page, above the definition of our main function, is we're going to put our import statements. So this is where you can import stuff from all over the place. I'm going to show you, we can import the class that we just wrote that's over in the classes.py file. And this is why it's important that you name it that too, so that you can make sure that you follow naming conventions. So when it's a file that you're importing, what we call local import, it's within the file structure that you're in, and it's one of your own files. You're going to use this phrase where you say from, and then the name of the file without the suffix, without the .py, just classes, which is what we name that file over there. If you're following along. And then the word import, space, and then the name of the class you want to import. So it's capital CAR. And now when I do that and I save it, that error or that little warning should have gone away over here. And this should work now. When I go back to, I'm going to go over to my console and we do Python main.py, it should give you the little thing that says that it's a Chevy Celebrity, 1987 Chevy Celebrity. And there it is. So what it does is when I run the Python 3 main.py, it goes to this file. It reads everything top to bottom. So it starts this import first. So it's going to go from classes. It's going to go find that file. It's going to read everything in classes and make sure that everything is good here. And it'll go back to main and say, all right, cool. I have this car class. And I'm going to read all the rest of the definitions you have. And it'll do all of that. And when it gets here and it checks this condition, it'll say, oh, yes, I was called as main because I was called from outside of this little world. I was called from the command line. It doesn't care where, but it was called as main. So it's going to enter this block of code, just like we've seen before. It's going to initialize that class. It's going to give it these parameters that we give it, and these arguments, and then it's going to call the method to announce its details and print them out here on the console. So
what
that
IDE is that you're using?
This one right here?
Not the Bash console, the other IDE.
So this is just built into Python Anywhere. This is all just Python Anywhere stuff, man. I'm not sure what they use in here in the back, but
no, I'm on Python Anywhere.
Yeah. So when you go up to files, and then if you just open a file, this is what it opens to automatically. Okay. Yeah. So if you open any of your files in there, it'll take you right to this. But so this right here shows how the modularity works in Python, and how we're gonna really be tapping this as we get through the web development portion of it. And this is how applications run and become more complex. So again, you could define a whole bunch of different classes in here, and then just import them in here, and then use them however you want to. And then every time you run this program, all you do is write Python 3 main.py, and it'll run everything that you pipe through there from however many files you put into it. So I know that was kind of a lot. Any questions up to now? That's really the last bit of sort of syntax and Python specific stuff we're going to do before we hop over into doing like the last bit of today. We're going to do some working directly with solving algorithmic problems. Any questions though before we move on any of the things that we did?
Okay, where you are right now. Okay,
Yes.
I got stuck here the other day where it says console closed. I
Yes.
couldn't figure out what to do next.
So that means that it's done. So like if you look at your list of consoles, let me refresh this. I destroyed the Python console that we were using in there in the classes file because I was, wanting to maybe run it from here from main, and I can only have 2. So if it says console closed, that means that one is actually dead and no longer exists.
Okay.
So this one doesn't. So if I hit run now, it's going to tell me that I've already used my limit and it won't work anymore because I already have 2 consoles open somewhere, or it'll just give me this white screen and not do anything. But that's usually the problem. If you get that console closed, that means that one of these just closed, and just go open another one. So here I have this one open in my main file.
It's still running. I don't know where I went wrong.
Yeah. All right, cool. Any other questions?
I gotta go through it.
Yeah. No, classes are tricky. And seriously, don't beat yourself up if you're not really grasping this fully right now on how to use them either. Because we're going to CMLize more to familiarize yourself with what it looks like. We're going to see them more. We're definitely going to get our hands on them more when we do Django stuff, because this is how the database is represented in Django. It's just a class. So it's good to know the structure of it. But when we're going into the next piece that we're going into with the solving problems and really working on practicing algorithms, you're mostly going to be here on doing functions. You're mostly going to be doing if logic, if then, if, elif, else logic. You're mostly going to be doing for loops. You're mostly going to be using strings and lists. The majority of the time, that's what you're going to be working with. So the classes and stuff that we went over, it's just like you can't really do Python without talking about classes. They're really the coolest part of the language. And we are definitely going to be using them later. So again, if this seemed like you're not quite grasping it, really don't beat yourself up. This took me a long time to fully get classes and how they work and what they do. But any questions that now that we've kind of gone over it?
Okay, I assume some point. Well, you mentioned the input function or something. I didn't get a chance to really figure out what it was.
Oh yeah, sure.
If you wanted to have just like an actual application where you would enter, you'd like call up a screen and you would enter things like model, make, and year on your screen, and it would populate like that.
Cool. Check this out. I can show you what to do. Yeah. No, you have a question? You raise your hand again, man. I can't hear you if you're talking though. All right. So Mike, I'm going to answer your question on ways you would do that. So I'm just going to do a quick example of that. So there's a built-in thing that's called input.
Input. That's what I was looking for.
Yeah. And so what we're going to do is I'm going to put a variable. They'll say like my make equals. They'll say input open parentheses, and then I'm going to put open quotation marks, and I'll put in a message like enter make of your car and a space. And I'll close that out. And what this is going to do, and actually, hold on. And then we put make. We have to change this out to my make instead of making it explicit. So the make of the car is going to now equal this variable of my make. All right. So on this line 32, what happens when we run this, when we go to main and we run it, it should display this thing that says enter the make of your car and expect the user to put in the make of their car. and then it'll do the rest of the code from there. So it'll stop here until the user puts in input, and then it'll run the rest of the code once it has that. So I'm going to save this and let's go give it a try, see how it goes. So I'm going to clear my screen off real quick. Same way we've done it before, just Python 3 main.py. Enter the name, the make of your car. So let's just say it's a Ford. And now it's going to do everything else that it did with that input. So now we say we have a Ford celebrity from 1987. So you could do that similar pattern with any of these and anything else as well. You could put in, kind of take whatever input. You could have people input integers. You could change the types of things that they put in. Just be aware that anybody that puts something in is always going to be a string. It's always a string when they type it in. So if you want an integer out of this, like if you want my integer, you have to wrap it in a the string, the built-in string method that will, or I'm sorry, the integer method that will turn that into an integer. That, you know, a number. And that way it'll change that into a number. So if you want to play with things that, you know, require an integer to use, just be aware that user input is going to come out as a string.
Okay, now we get an error message.
Uh-oh. Syntax error. Oh, because I didn't close my parentheses.
Yeah.
Second parentheses, always getting me. All right.
Okay.
So yeah, this.
Okay, now another question here. So when you're running a program like this, when you have two input functions, right?
Mm-hmm. Yep.
Okay, it would stop first at my make.
Yep.
And it would stop at enter a number.
Yep. And then it'll run the rest of it. So as soon as I enter a number, basically it'll spit out the details in a matter of milliseconds. So it'll seem pretty much instantaneous. And we don't have this returning anything for the number. We could print out the number or something like that to test it and play around with it. So, you know, say print my int. Save it. And then again, run it the same way we have for everything else. Change it back to Chevy, put 9 in there. And there we go. So print out the number, takes the input. Uh-oh. Yeah, Noah, what's going on, man? I can hear that you're, I see in the chat that you're saying your mic isn't picking it up. Can you type in your question in the chat? While you worked on that, Antoine, do you have a question?
Yeah, I had a question. I actually want to know why I'm just trying to see where I went wrong. I was trying to sort through it before I got to the course. Or before I got to X, I was trying to see if I could figure it out. But I don't know why my code won't. Put it, it's running, but it won't print, is what I mean.
Okay.
Like,
all right. Well, so let me get through this next little bit. It's like say we got 15 minutes. And then if you want to hang out afterwards, we can do that in a second. So, no, your question, do you normally run after 10 list or it depends? I'm not sure what you mean on 10 for the list, but generally speaking, loops. Yeah, no, it depends how many loops you want to go, right? So if you're doing for loop, it's however many items are in there, it's going to loop through exactly how many times. If you're doing a while loop, then it depends. There's no specific number. It depends on your purpose and what you're trying to do. So, I don't know. Hope that answers the question. Let me know if it doesn't. We can get back into it. All right. So employing these loops. Let's go quickly into the algorithmic practice. So I'm going to show you a couple of really great tools for practicing writing algorithms and solving problems for it. And that's really what I want you to do. I've put together a list of problems. I'm going to share this out with everybody. It's just a list that links out to 2 different sites. I encourage you to sign up for them. I don't think you have to sign up for the first one to use it. So if you really don't want to, you could just use it. And they're called Code Wars and Leet Code, respectively. Like the first 18 of these, I think, are on Code Wars, and the last 2 are on Leet Code. I'm going to show you what these are. So, Code Wars and LeetCode both do the same thing. They're made for training and practice. The reason I've got 2 on here is that it's CodeWord is more sort of like beginner friendly, and it's more just kind of cutting and working on your chops. Whereas LeetCode is really focused on getting you ready for those coding interviews and preparing for that. It tends to be a little bit trickier. The
What's the
criteria
name of the second one?
LeetCode, LeetCode, and both of these are listed in the resource list. They're linked in the resource list that I emailed out. So you should already have both of these accessible to you in that list. So they're already there. We're gonna be doing stuff in Code Wars today, and the assignments are mostly in Code Wars because again, it's more user friendly. The thing that's really cool about both of these is that once you solve a problem, you can see other people's solutions. LeetCode though is a little bit stricter because they have memory and processing power restrictions to pass one of these problems, right? So whereas Code Wars, you could pass with pretty inefficient code. LeetCode, your code has to be more efficient. So I see this more as a second step once you've gone through doing these a little bit, and then you're working on making it more efficient. LeetCode's going to be your spot, your place to be.
Right, because then it's not just solve the puzzle, let's solve the puzzle the
Solve
best.
it well. Yes, exactly. So I'm going to show you an example of, and I'm going to reset this because I was messing around with it earlier. So this is an example of what it looks like. And I've zoomed in a little bit so it can be large enough for people to read. But once you go into a problem, this is what algorithmic problems look like. So to orient you on the page, there's a bunch of stuff kind of happening on the top. We'll skip a lot of these. Over here on the left-hand side where it says instructions, underneath it is going to be the actual problem itself. So this one is write a function that would given a URL as a string, parses out just the domain name, and returns it as a string. And then it gives you some examples of what those things are and what would be. So I thought this is a really good example, even though it's not exactly the lowest level. This isn't one that I included in the practice list, but this is one I want to show you. Maybe if we got time, we could kind of work through a little bit together. But this is what they look like. So once we have this is the assignment, basically, the question that you're going to do. Oh, sorry, highlighted one I wanted to. Then over here on the right, under solution, kind of right center, this is where you're going to write your code. So it already has a function name for you. And this pass is just a way for things not to break when you run it, but there's nothing in it. So this isn't going to do anything yet, but you have to write your solution to this problem in here. And then down underneath it, we talked a little bit about testing, and I skipped over that because this platform will give you plenty of opportunity to practice with testing. They have tests already written into it. And we don't need to worry a lot about this, but you see there's some use of the import statements that we were just talking about. There are some other things in here we're not going to talk about, like these little at symbols that say at test. Those are just decorators, some fancy stuff we're not going to get into. The big thing we want to look at, though, is this assert equals statement. So this is going to say that this first string is the input, and the second string is the expected output. Now, this is the really common way to structure tests. And this, as you can see, has several tests built in. There's a handful of them already in here. And what you do when you run this, the little button down here says test. And I encourage you when you go to these first, before you write any code, do anything, just click the test button to see what happens. What it's going to do is it's going to run that test code. It's going to run the code that you wrote, which we haven't written any, so it's not going to return anything. It's going to return none. But once you do that, it's going to go over here on the left-hand side again and say the output. And this is going to say how long it took you to run your code, how many of your tests passed, how many of your tests failed. And you can select that. You say you show your past test, show your failed. This failed everything because we didn't put anything in there. But I want to show you how valuable this is for debugging and solving your problem, right? So it shows you the output that you got. Ours is none because we didn't put any input into it. And then it says it should equal Google. So if we go back over to our other side, that's the first test case here where the expected value is Google. So that's really the standard process here. Now, that's the test button when you press that. You saw down at the bottom, there's an attempt button. When you press attempt, there's going to be other tests that are in there. So just passing these tests may not be enough sometimes. You need to pass all the tests. That's general kind of format of how it is. Once you've solved one of these, you'll be able to click on this view solutions and see other people's solutions. So the way to practice with this is to try to solve it yourself as best you can using what you're going to do. And then once you do, and once you get a solution, go in and look at the solutions that other people have and compare it to that. So if we got a few minutes here, I was going to kind of go through like the process for doing this in general. And it doesn't involve any code. So the very big part that I want to hammer home, even if we don't get all the way through working through this one together, if we got to wrap up and some of y'all got to hop because we go a little bit over time, That's fine. The main thing that I want you to know is that when you're solving these problems, getting away from the code is the first thing you do. Don't start writing code right away. So what I'm going to do is I'm going to take this question and I'm just going to move it over to this blank piece of this blank document. Oh. I'll zoom in a little bit again so it's bigger. So it's the same thing. Write this function. I'm just copying and pasting so that we're out of this area and we're not tempted to write code right away. Cool. Well, actually, you know what? That came as a code block, and I don't want that. So these are just our examples. The same thing that was in there. Now, what I'm going to do is just what you need to do, and the reason I put this on another page is that you want to step away from that code and don't think about how you're going to actually write it. Just think about how you're going to solve the problem, irrespective of the code you're going to use. So if we look at this, a lot of times what you want to focus on is what the input. Remember back to our definition of an algorithm, right? So we're going to be writing an algorithm here, and remember the definition. So we're going to have it's got to be finite, so it executes only a certain number of steps. Those steps have to be very specific on what they do. It's going to have inputs, it's going to have outputs, and it's going to solve a problem. So the problem we're trying to solve here is we're trying to get a domain name out of a URL, which is the address of a website. And the inputs are going to be these full websites. They're going to be strings. So you see all these inputs are strings. And the expected output is just that domain name in a string, right? So we're going to key in on those things every time we look at this. What are the inputs? What are the outputs? Look at the examples of the input. Get a sense of what sorts of things that are there. So we're going to have to do some way of identifying this thing in a general sense. So we're going to look for patterns in these inputs and say, all right, well, generally speaking, there's these HTTP things in front, and then there's these slashes, and then there's the address. So that, that slash is good. If we could split up the string into parts, so I'm going to start jotting down the ideas of what it is I'm going to do to solve this problem. Again, this is not the code specifically, but I'm going to split the string into two parts on the slashes, right? And so then the first part I'm going to ignore. So I'm going to ignore the first part. The second part's going to have more of what I want. It's going to be this part. So once I've done this first step, it's going to be this part. And if I'm focused on GitHub, it's like, all right, well, I'm probably need to split it again on the dots. Most likely, it looks like the domain name we're looking for is in between these dots. So maybe we'll split the parts on the period. I'm going to put it in quotation so I can actually see that there's a period, and these are strings. And again, I'm going line by line. So this is similar to the code, but I'm being just explicit in what I'm writing. So I'm going to say, this is what I'm going to do when I get there. So once I have these parts split up, I'll have one part here. That's a www. I've already ignored this part. So I'm going to say, what? And so then I'm going to check to see, check if it's www. If the first, if the first part is www. If it is, we'll use the second part as the domain name. And if not, then use the first as domain name. All right, so that's generally kind of what I've spitballed as the solution to this problem.
Can I ask a question?
Sure.
Okay, that last statement there.
Yeah.
I'm reading that. I'm not, to me, it's real ambiguous. Okay.
Yep.
So this is after the split, after the dot, right? It's after it splits the dot at the dot.
Yeah. So the first time
Okay.
I'm going to split it up, take basically all this stuff and separate it into two things.
Okay.
And then I'm going to separate once again into however many things there are. And I'm going to check the first two things and see if this one is www. I'll ignore it and take the second one. And if it's not www, like in the case of GitHub up here,
okay,
after we do those same split steps, it should have GitHub in the front with no www. I'll take the very first one. So that's my approach to solving this. This isn't necessarily, again, this isn't the only way to solve this problem. This is just the way that I approached it when I solved this. So, and I'm trying to show you kind of the process for when you come to one of these. Writing it out like this can be called what's called pseudocode, like this.
Yeah,
This is kind of like code, but it's not. It's somewhat doing the things we're going to do, but it's not exactly. We're not worried about syntax. But it's going to kind of frame the solution that we're going to get to. Is everybody tracking on that? Sort of this is what we're going to do. If we want to make this solve this problem, we want to be able to get the domain name out of a URL. This is one way we could do it.
Michael making his peanut butter sandwich.
Making the peanut butter sandwich, exactly.
Yeah.
So we're thinking about it ahead of time. What are the steps for peanut butter sandwich? And we write it out as best we can. So then once we've got this, then we can flip over and we can give it a shot actually writing some code, running some tests, and seeing how it goes. So from here, we've got the split the string into 2 parts and do some other stuff with it. So back over to the code. Back over to this. I'm going to show you real quick a few things that I do out of habit, especially when starting out to alleviate frustration. We talked about inputs and outputs. So we've already got an input listed as URL. So what I'm going to do first is define my output. So I'm just going to use DN for short for domain name because the name of the function is already domain name. And we're just going to say DN equals, and we're going to say string because that's what's going to be out. And then I'm going to skip down a few lines and write my return statement and return that output. And a lot of times, seriously, when I'm doing these, I'm really thinking about how to solve the problem. So I'm going to do the solving in between. But to make sure that I didn't mess this up, I'd literally just name this output and then I remember to return my output. That's a totally viable way to do this so that you're not focused on little mechanics like this and forget to return it or something stupid and you're beating yourself up on your internal logic and it's not that. So I'm going to keep using.
What does DN stand for again?
Nothing. Domain name. It's just short for.
Okay. Just a variable name.
Yeah, variable name.
Okay.
We got questions. Somebody raise hand. Questions. Couple. So Antoine, do you have a question? If you did, you're on mute.
No, I didn't have a question. I'm still waiting until the class and
Okay. All right.
2 minutes.
All right. So we talked about the first step that we're going to do was we're going to split this into parts. So Python's got a really cool built-in thing for strings that's actually called split. And so what it does is it'll take apart a string at a character that you give it or characters that you give it, and it'll break it apart on those characters and return it'll return to you a list. So we're going to store that list in a variable, and we're going to call that parts because that's what we're going to, split it out into, right? So we do URL dot split, and our plan was to split it here and see where that goes. So now that should be using our examples. That should split into 2 things where we've got everything before the slashes, including the slashes in one group, and then everything after another group, right? And then we're going to want to do the words individually that are in that thing. We're going to try to grab the domain name out. We're going to split the first part. Again, we're going to ignore the first parts. We're going to take the first index, sorry, index 1, second index of that parts list that we know we got. We're going to split it on the period that we talked about. So that should be the second split that we needed that separates out the, github.com and the www.com. And now that we've done that, we have those pieces, we can do some simple logic. So if words, which is the second list of things, word 0, the first one, and this is where we're going to check to see if it's equal to the www, right? Enter a code block.
Typo. There's a typo on parts. It's URL, not USL.
Ah, thank you. Because I would have been annoyed with myself. Let me make those mistakes though, but I appreciate it. That's an opportunity for debugging, but thanks for catching that. All right. So if word 0 is equal to www, then we're going to set our domain name to, if you remember our logic, like we said, we're going to take the second one, right? So if the first part is www, we're going to want to take the other one as our domain name. Otherwise,
let me ask you something.
Sure.
Okay. I can't see for sure, but the www.
Yep.
If words, do you include the dot?
Nope.
Nope.
I'm just doing 3 because I already split it on the dot, so there shouldn't be any dots left. So
Okay.
up here on line 5, I split on the dot. So this is going to have, in theory, this should have the www and then the domain name and then whatever else is included after the domain name, all as separate strings. And so this is following the plan that we made. Let's see if it works. Let's run the tests and see what happens. Uh-oh. List object has no attribute. Split. So I forgot to call the part that we wanted out of this, and I called split directly on the list. So that's not really going to help us too much. So I'm going to say that it's going to be parts 1 because we're ignoring the first part. And we split it on this first step. We split it into the HTTPS and then the other parts. So let's try running that. And this should get us most of the way. So we passed 5, but then we ran into more errors. So what errors did we run into? So this says index error. The list index is out of range, and it tells us where. So it says line 5, the parts dot split 1. So that's still a problem. 1 still didn't work. Now, why would that be? So it passed all the tests except the last one. And if we go over here to our last test case, and we look at the input and the expected output, now this input's a little different than the ones we looked at when we were making our plan. So this doesn't have a www in front of it. It doesn't have any HTTP in front of it. So on this step, it doesn't split anything. So on this line of code, it does nothing. It splits it into 2 parts on this code, or it would, except we're calling the first one, we're calling the second one, the second one, which is the number 1 index, and there's only one thing here. So it's too long, what we're calling here. So a way around this is we can just check to make sure that this length is good, right? So it's some more conditional logic here and say, if the length of parts is less than 2, right? Meaning that there's only one thing in there, then we're not going to take the second one, obviously, because there aren't 2 in there. We're just going to take parts 0, and we'll split it just like we did on the period. And then otherwise, I'll take the one we had. Now, this should address this last test case. So when I run it this time, it should pass all the tests. Let's find out. What errors did we get here? Test 1. Wait, did I mistype something? I must have mistyped something. Oh yeah, right here. I just put in the brackets 1, so we're getting this the list of 1 instead of setting our domain name to the second part of words. I just set it to the number 1. So typo, and now it passes everything. So now it works. So now that we've done this solution, we can look at other people's solutions and view solutions. I know we're a couple minutes over, and I apologize for that, but here is the beauty of these platforms. So now we're going to go in here and we're going to see an actually efficient and sexy way of doing this. So look at this guy's code. I had like what, 8, 9 lines in mine. This guy did it in 1. Right. So I'm not going to try to show you that I have the best ways of doing it, but once you've solved a problem, you can come here and look at other people's solutions and be like, oh, this is one way of doing it. And then read their solutions and understand how they did it. And if you look, they didn't do much different than I did. They used splits. They split on the same things. But if you remember when I was talking about lists, if you use -1, it grabs the last part. And if you go back to our example inputs, that's the part you're going to keep needing, is keep grabbing the last part. So this is a really clever way of doing it, is just remembering.
He just did it in a way where he could type it on one line.
Yep. And then this guy did it totally differently too. He imported a package for regular expressions, which were really cool, but we're not going to spend a lot of time doing. And then he used this is a regular expression right here to do the parsing out. And then he used this built-in function of group and some other things of search. So there are lots of different ways to approach the same problem. And all of these are reasonable solutions. These all work. And so, solve these. I'm going to send out this list of problems that are going to be mostly in code words like we just looked at. These are ones that should be fairly simple. It's going to be mostly strings. It's going to be mostly lists. There will be a little bit of math in there, but again, don't hurt your feelings if it's too tough on any of these. The goal is to get yourself down to where you could solve these in like 45 minutes or less. Especially the easy one should just take a couple of minutes, like we just did. But it takes practice to get there, right? So this is the beginning of it. I have solutions to these 20. These last 2 are going to be on LeetCode. The top 18 are going to be on Code Wars. I have solutions to these. Again, they're mostly my solutions. Some are ones that I've found, so they're more efficient than the solutions I would write. But if you're really jammed up and really stuck on one, I can float you the solution to get you unlocked and look at other people's solutions. But I'm going to send this out along with the video for tonight. And I really, really, really encourage all of you to try to get through as many of these as you can by Thursday. We're going to talk some more about it. We can even go through some of these if you want to, and go through solve them if you like. And maybe I'll have some of you explain your solutions to these. But that is it. I know we're a few minutes over. So thank you all for staying with us until the end of this. Are there any questions about any of this before we wrap up for the night?
Yeah, I need to see the video again.
Excellent. Yeah, no, there's a lot of stuff. And again, this week is fairly complicated in a sense. And so I want to give us, plenty of time to practice and get your hands on it and do these things and work with it and, break it as much as you can.
All right.
All right. Anything? Yeah, no, sorry, your audio is not working, man. If you want me to hang out for a minute, we can look into that. Antoine, you too. Are you going to sign off? All right.
Yeah,
Good night.
yeah,
Now.
I am.
Yeah.
That's what I was waiting for you to.
Cool. All right, then I can. If there's no broad questions
like,
for everybody, I can stop the recording and then I can hang out and we can go through some more stuff if we need to and talk about your specific things like Antoine or anything else that we had questions on.
Yeah, I just had I'm gonna wait till you stop. You want me to wait till you start recording?
All right, I'm going to stop the recording and then everybody else absolutely going to stop recording and do you want to stop cloud